welcome back to another episode of Foundational Algebra, looking at Algebra 1 and Algebra 2. I am your lovely host, Mrs. Audrey Connor Gibson, and I'm feeling a little islandy today. Got a little side ponytail here. I'm looking kind of cute. Okay. So what we're actually going to be doing today, let me share my screen with you guys so we can get started. So we're looking at relations and functions. And you're probably like, all of a sudden we went to a relationship show, Ms. Gibson? I'm like, no. No, mathematical relations and functions, okay? So we're looking at the Common Core Standards of AREI 11, ooh, we're getting fancy, and APR 3. So we're still looking at the algebra components, but we're looking at how relations and functions work in the mathematics world. So our learning target and agenda, I can identify the difference between a relation and a function and classify the domain and range. So we're looking at some different terminology. So we've got to figure out what a relation is. We got to figure out what a function is, domain and range. So our agenda is we're going to look at the exit tick answers from last time. We're going to do some guided notes and some guided practice and examples. And then we're going to close up with the exit ticket. So let's take a look at our exit ticket from last time. So we were working on plotting points on the coordinate plane. So remember, my x-axis and my y-axis is basically two number lines intersecting at the common point called the origin. And it broke up 4 sections, which are called my quadrants. So remember, this was quadrant 1. This one was quadrant 2. Here down here is quadrant 3. And lastly, quadrant 4. And they always had to represent that as Roman numerals. So I asked you to plot these points on the graph. So if we were to plot point W, it's at -2, 6. So starting at the origin, we go to the left 2, and we're going to go up 6. And we're going to plot our point, and that'll be point W. So for point X is 1, 0. So starting at the origin, we go to the right 1, and we don't go up because it's 0. So that's going to stay right there. And that X point X is also known as my x-intercept because it's intersecting the x-axis. Then we have for point Y, -2, -1. So I went to the left 2 from the origin and then down 1. So that's my point Y. And then point Z is going to be 4, -3. So I go to the right 4 and I'm going to go down 3. So that'll be point Z. All right, so that's what we had to do for the exit ticket for last time. So now we're going to look at relations and functions. So helpful hint, a relation is a set of ordered pairs. So anytime you get an X value and a Y value, you got a relationship because whatever happens with the X values, the Y value is depending on it. Okay, so the X value is your independent, usually using time, years, things that keeps going, okay? And what you do during that time will depend on it. So that will be your Y values. So the X values in the set of the ordered pairs is called your domain, okay? So the list, the whole entire set, all the X's that's being involved in ordered pairs is called your domain. Now the Y values, that's called the range, okay? So you have your domain, which is the set of your X values. Your range is the set of your Y values. So now a function is a special relation in which each value of X is paired with exactly one value of Y. So if we think about relationships, okay, you can date how many people you want to date. Just try to keep it clean, try to keep it cold, okay? But when it comes to a functioning relationship, it's usually between one person and another. It doesn't matter. It could be boy, girl, boy, girl, boy, whatever. Whatever floats your boat. But my thing is to have a functioning relationship is going to be one person with exactly one person. So a relation is a function when the X values do not repeat. So you can't have multiple X's for one Y, okay? And it also has to pass a vertical line test. So one thing that I always like to say is if I say a person's name, so we got Todd, we got Mary, Sue, work with me people. These three people can have the same birthday. That's possible. But is it possible for Todd to have more than one birthday? And I'm not counting that whole thing called leap year, stop it. But I'm saying he was actually born one time. He wasn't born multiple times. So that's why we always want to say that Todd can't have more than one birthday. Todd can have one birthday. Mary and Sue can have the same birthday, but one person can't have multiple birthdays. So we always want to say a relation is a function when your x values do not repeat, okay? The y values can repeat all day, but the x values cannot. So let's get with an example. So we have a set of ordered pairs. We have 2, 3, 3, 4, 4, 5, 6, 7, okay? They're all part of the set named R. So if I needed to list out my domain, I'm going to list out my domain as a set. So I have the set of X such that, okay, the set of X such that, and I list all my X values. So my X values always comes first. So it has 2, 3, 4, and 6. So when you list out your domain, you have to list it as a set, okay? So now if I do my range, I have my set of Y's, okay, such that, and I'm listing out my Y values. So I have 3, 4, 5, and 7. So my X values, if I write it like this, we got X comma Y. So my X values always come first and my Y values come next, okay? So if I were to plot these, I have 2, 3, so that'll be this point, 3, 4, 4, 5, and then 6, 7 will be somewhere up here because we got 6, 6, all right? So if we take a look at it, it's almost like giving me a straight line, okay? It's almost increasing. But if I do what's called a vertical line test, vertical means up and down. So if I have a line that's going straight up or down, okay? If I move this line over, it should only hit one point at a time. If it hits more than one point at a time, it is not a function. It's a relation, but it's not a function, okay? So a relation is the set of your ordered pairs. But a function is when you have particularly one X with one Y, okay? So if the set of F equals 3, 2, 4, -1, and 4, 7, is it a function, okay? This is a relation because it's a set of ordered pairs, but is it a function? In my case, I would say no. And why is it not a function? Because look at my X values. My X values are repeating at 4. So they're asking us, what is the domain of F? So I write my set of X such that, and I write all my X's. So I have 3, 4. Now, I don't have to write the number 4 twice, okay? All I have to do is write it once. So that's my domain. So now we want to explain it by using the vertical line test. So let's graph our points. So we got 3 and 2. The X value is 3. The Y value is 2. Then we have 4, -1. And then there was also 4, 7. I love picking points that's off the graph. But if I drew a vertical line as best I can, okay, this one, yeah, it goes through one point. But when I come here, this vertical line goes through 2 points. And that's telling me that my X values are repeating. So it really fails the vertical line test. because it only can pass the vertical line test if all your points only goes through the vertical line at one time, okay? So continuing on, we got set R. So we have 1, 2, 2, 3, 5, negative 6, and 9, 7. So we're going to answer the following questions. So what's my domain? So that means we're doing the set of my x's such that, and I list all my x's. So I got my 1, I have 2, I have 5, and I have 9. So you're probably saying, well, do we have to put in algebraic or at least numerical order? It would be nice, okay? So now list the range. So it's going to be the set of my y's such that, and I list all my y's. So we got 2, we got 3, we got negative 6, and we got 7. But didn't you tell us we had to put in numerical order? All right, let's do it. So the set of y such that negative 6, 2, 3, and 7. Okay? I would take either one, but we like to be professional with this, okay? So all you need to do is make sure when you're listing your domain, you have to list it as a set. If you're listing your range, you have to list it as a set, okay? Now, is it a function? So which one should I look at? Should I look at my domain or should I look at my range? Which one? Hopefully you're saying look at the domain. And if any of those numbers are repeating, is it a function? It won't be a function. But in this case, is the set of R, the domain of the set of R, a function? Yes, it is. Because my x's do not repeat. Or I should say don't repeat. Okay? All right. So, looking at our target, I can identify the difference between a relation and a function. So a relation is the set of all your order pairs, and a function, you have that distinct one-to-one. And do we classify the domain and the range? So the domain is the set of your x's, and the range is the set of your y's. And I want to say that we definitely looked at that. Boom. So we did our exit ticket, answers from last time. We did some guided notes and some examples. Did a little practice. Now we're going to go to our exit ticket. So this is what I want you to do for set T, which is 1, 2, 4, negative 3, 5, 7, and 3, negative 3. I want you to answer the following questions. List, well, it's not really a question, but list the domain of T, list the range of T, and is T a function and why? Okay? So, taking a look at today's lesson, pretty short and sweet, right to the point. So if you need any more assistance or if you want to continue watching the videos, continue the likes. I love doing them. So if you need any assistance and you need private tutoring, just get in touch with me through ACG Math Tutoring, and then we'll take it from there. So hopefully everybody's doing okay, and I will talk with you soon. Take care. Goodbye from the island, woman.